Let's take a look at the process for creating model-based definition for this flange part here that we have on our screen inside of an Onshape publication. What we'll do is actually start this part from scratch, generate the initial sketches and initial dimensions, show how the model-based definition is applied during the modeling process. All right, let's jump back here to an empty part studio inside of Onshape and start sketching out the side profile of the flange. All I'm going to do here is just kind of whip in the shape of the flange as if it were done in a done on a lathe, like turned part, right? And I'm going to dimension the parts. You notice how I'm dimensioning. I'm dimensioning from face to face or line to line instead of like just one line at a time. And that's precisely because with model-based definition, you need to dimension the faces, right, for inspection. I just set my units here to metric instead. And I just turned that dimension tolerant and applied a basic dimension to it because it's the feature of size. I'm going to have geometric tolerances and datums and things like that. So we need to set those tolerances up as basic. And that's what I'm doing right here, just by setting it as tolerant and then applying my basic tolerance on these flange thicknesses here. You notice I'm not going to go ahead and like start trimming this shape up. And Onshape, you can revolve this shape without having to do a lot of manual trim work, which will end up breaking a lot of your relations sometimes. So I often will just leave it like this. And I'm going to add my other dimensions too for the OD for each of the flanges here. And of course, I'm just going to, type in half the value, right, for the radius. So go ahead, place those in. Dimensioning from a center line gives you this this option essentially to dimension a radius, as a diameter essentially, right? Because you got to be revolving that shape. Now, I'm not actually going to apply toleranced values to the revolved shapes here because I want to apply those dimensions differently later, applied manually essentially, because I want to dimension them a certain way for inspection. But this was the best way to parametrically create the sketch. So now that I have that, I'll just revolve that shape without having to trim. And, we'll just change the color of it. Stands out a little better. All right, let's take a look at a section view. We can actually work while we're in a section view inside of Onshape. I tend to do this a lot when I am working on an axisymmetrical part like this. So, all right, so let's, or a turned part. So let's apply a circle here for an embossed shape for a bearing here, and I'm going to apply the tolerance values directly, as I'm constructing this, right? So I can set it to deviation or limits, just like the other ones were set to basic. And of course, I'll just create my extrusion. And in your extrusion box, you also have the button right there to set your tolerance option and the actual value. And what you see right there was a tolerance value, right? That tolerance value table will actually calculate your upper and lower limits for you. So you don't have to do the hard work that you would normally have to do to transcribe the upper and lower range of those tolerances, right? So Onshape is automatically giving us a table experience for that. And you can see that as we have cross highlighting. As I select things, you're seeing things highlight in multiple places. So I'll leave that table on so we can see the effect of our tolerances as we extrude things. You only will see the tolerance data in the table once you actually have committed to 3D solid geometry. I'm applying a hole tolerance with a hole fit, transitional fit, for this right here. So that's also included. It's not just numbers you have to type in. You can pull from standards. Not only standards for holes, but standards for entire tolerances like ISO tolerances and ANSI standards and things like that. All right, I'm going ahead and doing some lineup work now. So you can actually use like traditional Onshape relations like coincident and parallel. See there's buttons for them at the top of the inspection panel to help kind of lay out your, dimensions in a way that's pleasing visually, because we're not creating a drawing here. We're creating, views essentially of a 3D model with the information that we want. All right, I'm just going to go ahead and add a bolt circle right here. All right. I'm not actually going to make that taller because I'm going to dimension that differently for inspection. But I did want the bolt circle defined that way because if I change my model parametrically, I want the bolt circle to update the way I expect it to. All right, let's just drill a hole right through here. We can make that tolerant or not and apply tolerances just like so. So pretty cool that you can do that right in the whole feature. It shows up in your characteristic list as you go ahead and place this information in. Adding geometric tolerances, of course, you pick the feature itself and you can, apply the geometric tolerance like a true position tolerance or surface flatness, things like that, directly to the faces of the model. And you'll say that here in this publication. So, it took me another 10 minutes or so to apply all the tolerances that I want after thinking about the layout and everything, getting it all laid out. And I applied some named views here to make it easy to look at, some of these options. All you have to do is just create a save name view and share that publication, and everything's good to go. Just hit that share button and your vendors now have access to your tolerances so they can manufacture your part. Or you can do it yourself if you have your own shop, right? So hopefully this helps clear things up, and let's talk about MBD some more.